Good morning, everyone. I am so excited that you are here today to talk about exponential growth and exponential decay functions. So before we get started, let's look at this first box. So I'm asking here, what do you notice or wonder about this first box? So go ahead and in the side box right here, go ahead and write down what you notice or wonder. All right, so you might have noticed or wondered a whole bunch of things. For instance, this is a Final Four March Madness bracket, and we are close to March Madness, and I think it is happening this year, so yay for that. And so March Madness is a form of exponential decay, and what it does is it starts off with 64 teams, and then after each individual round, one team is eliminated from each separate area. So it's halved each time. So 64 go to 32 teams, go to 16 teams, go to 4 teams, go to 2 teams, and then there's a final winner. And so when we talk about exponential functions, you're going to see them look something like this graph that you see down here. So you have it starting off really at a slow pace and either drastically raising or going up higher or drastically going down. So for instance, in the case of March Madness, if we were to draw a graph for March Madness, it would start off really high and then it would make its way down until we have a winner. Because remember, we have starting off with 64 teams and then we go to 32 teams and then we go to 16 teams and 4 teams and then 2 teams. And you'll notice that the gap between the two numbers starts off really high and then it gradually gets less and less and less over time. And that's essentially kind of what our exponential growth and decay functions are going to look like. And so today what we're going to be doing is we are going to be learning about how to graph them. So biggest things that you need to know is the reference points. Okay, so we have 0, 1 being our reference point and 1 comma B. Now B refers to our base. So if you look in the very top of the note page, you see how it's AB to the power of X minus H. So B is our base. So we're going to always have a reference point of 1 comma B. Another thing that you want to note is that we have an asymptote at y equals k, okay? So an asymptote is essentially an invisible line that your graph cannot cross. So basically what's going to happen with exponential functions is it's going to get closer and closer and closer and closer to that asymptote, but it will never cross that asymptote. Some other things to note here is just basically our key features, so our domain and our range. So our domain will always be negative infinity to infinity. Our range will be based on our k and whether our a is positive or negative. And then again, our end behavior. And so again, our end behavior is going to be based on that a as well and what our asymptote is on top of it. So let's go ahead and get started, and I'm super excited to talk to you about graphing exponential functions. All right, everyone, so we are going to be doing our first example here in graphing our exponential function. So you'll notice that I have listed the transformations that are above. So A, H, and K are still the same. So our A being our vertical stretch and compression. Remember though, if A is negative, it's going to be reflected across the x-axis. Our H moves us right or left, and we're always taking the opposite sign of it. And our K moves us up or down, and it is exactly what it is. Now, notice the different thing that's going to be here is our B, which is the base of the exponent. So if B is going to be greater than 1, it's going to be an exponential growth, which means that it's going to go in an upward fashion unless there's a reflection there. And if B is in between 0 and 1, it's going to be an exponential decay. So let's look at example A. Again, just kind of follow along with what you're seeing for this one, and then I will want you to try on your own for the next few examples on the next page, okay? So very first thing we want to do is we want to identify our A, B, H, and K. So our A here is -3, which means that it's going to be a vertical stretch and there's a reflection. Our B here is 2, which means that that's our base and it's going to be an exponential growth. Our H is 2, which is going to be going to the right, and our K is 1, which means that we go up 1. So from here, what's a little bit confusing is we're going to go ahead and use our 2 reference points that we are going to start with. Now, the one thing that you want to note is that our reference points change. The first one will always be 0, 1, but the second one is dependent on our b. It's going to be 1, b. And so since our b in this case is 2, that's why we have 1, 2. Now, I'm not sure how your teacher taught you how to do your transformations from here. So I might be doing them a little bit differently than what you're used to. So kind of just bear with me and watch and see what's going to happen. What we have to do is we have to first modify using our vertical stretch. So our vertical stretch is -3. So we're going to have to multiply our y values by -3. And so the reason why our y values are affected is because of the fact that think of, our A is our vertical stretch. So our vertical stretch going up and down, right? So when we talk about the up and down axis, that is our y axis. So it's only going to be changing our y values. So notice that we didn't multiply the 0 from 0, 1, or we didn't multiply the 1 from 1, 2, only the second value, okay? And then what we do is we're going to manipulate the points using our h and our k. So h affects the x values and k affects the y values. So again, think of it like this. H moves right or left. What axis is right or left? X. K moves up or down. What axis moves up or down? Y. And so when we're doing this, we're going to add 2 since h is +2, and we're going to add 1 since k is +1. And so we're just going to add it to each of those variables or those values. So 0 + 2 is 2, -3 + 1 is -2, 1 + 2 is 3, and then -6 + 1 is -5. And so these become the 2 points that we're going to be graphing, okay? Now, before we actually convert or actually graph this exponential function, we have to put an important piece out there, which is our asymptote. Our asymptote is always dependent on our k value. So k is equal to 1. And so what we're going to do is we're going to draw a dotted line through the 1 value on y. What this means is that when we graph our exponential function, we do not want to go through that dotted line, okay? So we don't want to go through that dotted line. So our graph will look something like this when all is said and done. And then lastly, we do want to mention what our domain and our range are. And so when we're dealing with domain's always going to be -infinity to +infinity for these functions because we'll go forever and ever left and forever and ever right. And then range is going to be based on whether we go forever and ever down or forever and up. So you can see that the arrow goes forever and ever down. So we're going down to -infinity. But the biggest thing that we can go up to is 1. Now it doesn't include 1 because remember we can't go past our asymptote. And so therefore we're going to use the parentheses here for our range of 1. So what's going to happen now on the next page is I'm going to go through this. But again, what I would encourage you to do is I'd encourage you to pause the video, try a couple problems on your own first, and then watch the video to see where the rest of the problems lie. Because again, I go through this pretty quickly and I want you to get a better understanding of if you're doing it correctly or not. All right, so we're gonna go ahead and do 2 more examples to hopefully solidify this idea of how do we graph exponential growth and decay functions. So like we did on A, the first thing we want to do is we want to identify our A, B, H, and K. So in this case, our A is 3, which means it's going to be a vertical stretch. Our B is 1/3, which is our base, so it's going to be an exponential decay. H is -2, so we're going to move left 2, and K is -4, so we're going to move down. Now also make a note that this is also our asymptote. And so we always want to start with the reference point 0, 1, but remember that our second reference point will be 1, B, and in this case our B is 1/3. Once we have our 2 reference points, we're going to multiply them by our A. And remember that we only multiply our Y values by our A. So again, we're not going to be multiplying the X values. So 1/3 times 3 just gives me 1. So now the fraction's gone, and 1 times 3 is 3. And then lastly, we're going to take into account our H and our K. And remember the H shifts the points left 2 and the K shifts the points down 4. And so if we were to manipulate these, our end points would be -2, -1 and -1, -3. So we can go ahead and put those 2 points onto our graph. But before we connect them, again, a biggest thing that we want to do is we want to make sure that we graph that asymptote, which is going to be our K. This really helps solidify how the curve is going to be drawn. And if you don't have that asymptote in here, then sometimes our curves can get a little wonky. And so again, remember that we never want to go through the asymptote. So our curve is going to look something like this. And now we have our beautiful exponential decay function. Lastly, we want to make sure that we include our domain and range, our domain being negative infinity to infinity, and our range being from -4, which is our asymptote, to infinity. At any time, if we go too fast through these videos, remember that you can always pause, rewatch, write everything down. I don't want you to get too confused, but please remember to ask questions if you have any questions as well, okay? All right, so let's go ahead and go to C. So C, we're going to identify our A, B, H, and K to start. Remember that our A is going to be our vertical stretch, our B is going to be our base, and in this case, it's going to be an exponential growth because B is 4. We have no H because there's nothing in the exponent besides just X, and our K is -3, so we're going to move down 3, and that will also be our asymptote. Again, we're going to start with the same reference point of 0, 1, and then 1, comma B, and in this case, our B is 4. And we're going to always start by multiplying those y values by 2. When we multiply those y values, we end up getting our new reference points of 0, 2, and 1, comma 8. And then lastly, we're going to manipulate them with our h and our k. And so h is 0, so essentially the x coordinates don't change at all from the beginning to end. But our y values are going to change, so we're going to subtract 3 from each of them to give us 0, comma -1, and 1, comma 5. So we can graph both of those points, but again, before we connect them, we want to make sure that we have our asymptote, which is going to be our K, which is -3. And then our curve, you'll notice since this is a growth, our curve is going in an upward fashion instead of a downward fashion. And so although that doesn't really affect our domain or our range too much, it does make our graph look slightly different. Okay, the last thing we're going to do is just kind of summarize what we've learned about these two different functions or how it changes. So you see the summary, it says, in your own words, explain the difference between 2 to the power of x and -3 to the power of x. Pause the video and then I'll explain what I wrote. All right, so what I noticed here was that 2 to the power of x is an exponential growth function, meaning that it's going to start low and go up high. And because of that, our range will be from 0 to infinity. 0 coming from our k value, which there is no k value, and so it goes from 0 all the way to positive infinity. -3 to the power of x is also an exponential growth function because our b is 3 here. But because our a is -1, it's going to be a reflection. And so because it reflects, the range will change and thus it will be -infinity to 0. And so it's reflecting across that x-axis. So although our k is still 0 here, because it reflects, it goes all the way down to -infinity up to 0. All right, well, that concludes today's notes. I will be covering some of these again in class just to solidify the graphing understanding, but please make notes of what you need help with, what you're confused on, and then we'll kind of go from there. Thanks so much for joining me today, and I'll see you guys in Zoom.